Thank you, Mairead. Delighted to be here, delighted to be given the opportunity to talk on behalf of the ITFMA, Irish Timber Frame Manufacturers Association. As Mairead was saying, I actually work for Fasthouse, which is timber frame business. We have 3 manufacturing plants, 2 over in the UK and 1 in up the north in Derry. But today I'll be representing the Irish Timber Frame Manufacturers Association. So just a bit about us. Established in 1991. We have 17 manufacturing members as it stands today. And then we have another group of associate members, which would be supply chain partners. So timber frame has gone from strength to strength. We effectively had 37% of housing schemes in 2019. We're up to around 48% is what's calculated for last year. So we're expected it could easily achieve 70 to 85%. We use Scotland as the example, where 85% of housing schemes is timber frame. So it is grown from strength to strength, which I'll explain the reasons in 1 second. So the association was brought together effectively to provide better quality and standards in the industry, and to protect our market, develop it further, and then just to encourage the specification of timber frame. Basically, anyone who's a member of ITFMA, a lot of them are the first tier manufacturers that would be synonymous with professionalism and trying to improve technical standards. So basically, as the trade association, we work with the likes of NSAI in developing the standards and continuously improving the Irish Standard 440. We work with the Department of Housing, generating technical guidance documents. We have our own Part B supplementary guidance document for fire, and we're currently developing a second one for 1 hour assemblies that'll get us into more use in apartments and duplexes, etc. So that'll come out later this year. We're carrying out fire testing as we speak. And we also developing a timber frame erector scheme, basically where we have, I think it's around 280 now erectors registered, and they actually have to carry out examination online and stuff to be approved. So it's just it's still very much in the development stages, and we're just trying to see how we can enforce it at the moment. That's where the struggle is. So why timber frame is increasing in popularity? It's the same benefits as any offsite construction. I won't harp on about them. Really, we are selling reduced build times. We're selling a much faster build, so that's reduced prelims. Overall program costs are down. You get more predictability in your program, in your costs, and then very important is to reduce labour on site with shortages of skilled labour. More and more off-site construction has been used. It's precision engineered in a factory controlled environment, so we're less dependent on weather. So basically we're starting the construction process in a factory while it's getting started on site, and that's where the speed comes in. I know I'm here to talk about IS 440, but I take every opportunity to mention that timber is the most sustainable way to be building. We have to talk about carbon capture and storage, because we have government targets now that we're trying to meet. So just a brief overview. As we know, forests, trees, they're capturing the carbon from the atmosphere, producing oxygen through photosynthesis. But basically what we're doing is every 60 to 80 years, we're harvesting those trees, and then we sustainably manage the forest. So we're actually growing more than we harvest. So you're creating a new carbon sink every time you're planting new trees, which are fast growing. So we're absorbing more carbon dioxide. And then when we cut these trees down, 50% of the dry weight of that timber is still carbon. So that carbon is stored in it for the life of the timber. So if we put the timber into buildings that can last another 100 years or so, you're storing the carbon for the life of the building. So that's the real the idea behind it. As it stands, we are trying to get net zero by 2050. We're trying to reduce carbon emissions by 50% by 2030. But if we look at the actual government targets and trying to build 400 houses by 2030, the Irish Green Building Council actually done research into it, it's actually shown we're going to increase our emissions by 5 times, not reduce them. So we'll probably continue to fail on these energy targets. We're purely looking at operational carbon. Embodied carbon is the next stage now to look at, and that's where timber comes in. So I'll move on then just to timber systems. There is various types. You see modular, we call 3D volumetric in the industry. You've panelized, which is a post and beam construction, 2D. CLT would come under that, and then you've panelized 2D, which is a platform type construction, which is your traditional timber frame that we're talking about. So it's not a modern method of construction. Everyone throws it in the same. It's around a long time, although it has developed. It had a lot of problems in the early days. We've been building timber frames since after the war era. So basically in the 50s, there's timber frame started to get built. Then we moved on to the 70s, where there was a boom and there was a new generation of timber frame being built. I suppose it has developed quite a lot over time. There's still evidence of houses that are built from the war era still standing. So it's definitely not a modern method of construction. There's various quality standards then. I just threw up what Fasthouse have, but the ISO international standards, if you have an integrated management system based on those, you're taking a lot of the boxes for quality management, environmental management systems, health and safety, etc. The key one we're here to talk about today is the Irish standard IS 440. So any modern method construction, you're trying to obviously show compliance to legislation. You're trying to prove that you can comply with the 12 parts of our building regulations. And one of the easiest ways of doing that, you can either prima facie guidance to give sufficient evidence as following the technical guidance document, or you can have your own national technical specification standard, which timber frame has. A lot of the other modern methods of construction, you're trying to show alternative methods of compliance. So we basically have all the accepted construction details. It's fully tested. So it's a well trial and tested form of construction. As I mentioned, we have a supplementary guidance document for the fire. We have another one coming out for 1 hour construction. So it's quite a bit advanced. Effectively, this one thing that's worth noting is it's not just dwellings. It does cover other buildings. It does cover on-site and off-site. If you're following ISO, you could effectively build a timber frame on-site. If you're not following ISO, or you cannot demonstrate that you're following the ISO and have an NSAI certificate, then you're into an alternative approach. 2024 amendment is worth mentioning. We do have that coming out later in the year, which is probably looking more at different wall build-ups will be introduced, different external cladding options. So it's just developing it that bit further. As I mentioned, design life is 50 to 60 years, but with proper maintenance, there's no limit on an actual building. If you maintain the cladding on the outside, timber frame can last indefinitely. So failing to have a national standard, the alternative approach method then, good document released in March 2024 explains it quite well. So basically, you don't have sufficient evidence, you're not following technical guidance document, you're falling outside it, so then you have to use alternative methods. And an alternative approach, if you are going down that route, you need to contact local building control very early on in consultation process, and then you've fire cert application and stuff needs to go in very early, so there's a bit more involved in it. There's what they call alternative standards. You can use other approvals from other jurisdictions. There's a bit of confusion around this. We've found, especially when it comes to external claddings, we can and can't use. So I suppose the confusion is people look at Technical Guidance Document B. We look at the harmonised standards and European technical assessments, and we say, well, hold on, it clearly states you can have an Irish standard, an Irish argument cert, or alternative national approval specification, or any state any state which is part of the European Economic Area. So the harmonised conditions are for marketing construction products. However, each member state has its own national legislation you still have to comply with. So you could have a German standard, say, for a building system, but you still then have to go through the 12 parts of and prove compliance. So you just can't come up with an ETA and say, well, this is fit for purpose in Ireland. So that's where a bit of confusion is. So what I suppose where we're going with this is you can have the NSAI Irish standard that is shown you have complied with the 12 parts of the Irish regulations. What others are doing now is they're getting an alternative third party, and they're doing a verification process. And it'll mention it in the certification then to say that they have actually assessed it to demonstrate compliance with the building standards here in Ireland. And my understanding, once you have this within your agreement cert, it should be fit for purpose. So just to give an idea, but I suppose we don't have to worry about alternative approaches. Timber frame in Ireland is covered under an Irish standard. The scope of the standard, 4 stories, maximum height of 10 metres to top floor, maximum fire resistance 60 minutes. Key is drained and drained ventilated cavity. So that's limited us to, well, we don't limit to any exterior cladding. Some people believe it only covers masonry outer leaf. Once we maintain a ventilated cavity, you could effectively put anything on the outside once it carries its own approval, or own certification. So it's excluded from the scope of IS 440 what you actually clad the outside of your building with. Roof coverings, external envelope on the outside is not covered within the standard. Once you have a drained ventilated cavity, you could effectively put anything on it. So it covers panels manufactured using mechanical fasteners. That's key. So you can't basically use a SIPS panel. You can't bond timber to an insulation core. You couldn't have the cross-laminated timber where you have different lamellas cross-bonded. It's actually a mechanically fixed, so it's your typical stud wall type construction. Maximum stud center 610 mil, and it does include the interfaces with the external envelope. So it doesn't include the actual whatever you put on the outside, but we do have to cover the interfaces with the timber frame. Excluded from IS 440 substructures, foundations, your wall panels fabricated on site. Well, you can fabricate, if you're fabricating to the IS 440, you could stick build a house on site in theory, but it's not going to be done in this day and age. So I just adapted a fire presentation I'd done previously, so I will not go into depth in this. It goes on and on. I'll fly through quickly. It's more to demonstrate the level of detailing that the timber frame industry in Ireland has. I suppose what's happened is the impact changes of Part L. As Part L start bringing down, if you look at walls from 1991, 0.55 U values, and we're down to 0.18. So what's happening is we were trying to make more energy efficient buildings all the time. We were encouraged to put more and more insulation into the walls. And as a result, that became more and more plastic foam materials going in, and effectively we were just worried about heat loss. And also then you have to look at what impact does that have on fire and other details. So that's what brought about the supplementary guidance document B. We've effectively narrowed it down to 4 wall types. So you have a wall type 1, which is probably the most standard product you'll see there. It's PIR continuous to the inside the stud, wool material in between the studs. 2 is what we're promoting more and more, which is basically a wool only panel. Again, you have your service void on the inside. And then 3 would be PIR between the studs, and wall type 4 is PIR between and continuous on the inside the studs. So effectively, we're trying to move away. The more embodied carbon calculations and carbon analysis we start carrying out, the more we want to actually omit PIR out of the wall types. So we're going for a wool only wall, which also has the additional benefit of a non-combustible solution. We've done analysis proving about 1.5 tonne of carbon can be removed from a pair of semi-Ds by actually just taking out that PIR from the external wall envelope. And then there's, as I mentioned, there's the additional benefit of fire and smoke by removing it out. So just I'll fly through these really quickly to just show the level of testing that's been done on. We've internal wall assemblies. There's various roof truss assemblies, so depending on the thickness of the truss cord, the centres it's at, depending on whether you're cross battening below to create a service void or you're direct fixing plasterboard, there's a full suite of tested solutions out there. The party wall detail is fully tested, so it's a twin leaf party wall. Part of IS 440 is you have to manufacture it off-site in the factory control environment. That includes the full dry lining of it, so you have to put on the plasterboard in the factory. We wrap it then with a protective membrane coming to site to protect it from moisture damage, and that'll be the standard wall type now. And we're just going into floor cassette assemblies. So posi joist floors are by far the most common in your typical dwelling, because just that open web to allow ventilation units and services penetrate through freely. We've tested now various posi floor joists to try and use them for 1 hour compartment floor. They're ongoing at the moment, those tests. That's your typical floor cassette that can be used in compartment at the moment. That's fully compliant with the technical guidance document. So without having to rely on test evidence, you can just use this build up, and at part E and part B, it's within in the guidance document. It's a solid joist floor. It's not ideal because it's very labor intensive on site. There's quite a bit of layers to it. Part E and B, and then this is where we're going with it, trying to get the posi floor has had acoustic tests and stuff done, but that'll be hopefully part of the next supplementary guidance document, so it's within prima facie compliance. I'll fly through these. This is just more to demonstrate that we have a wide suite of approved details. That's all tested, just showing different fire protection of encasements. And there's fire treatment around socket boxes, etc. It's all fully trialed and tested. That's just showing your boxing out details for service risers. Then if you've penetrations going through a separating floor or above a separating wall, there's various penetration details, ventilation duct and so on. I could spend a separate presentation just on fire stopping details. The party wall is an important one. The timber frame manufacturer is fully responsible for doing all the fire stopping that goes up over the eaves level. There's a lot of detail in the soffit boxes, non-combustible boards. There's in the cavity void between them, but fully responsible for all that on site. The installer and manufacturer is fully responsible as well for all the fire stop locations. So you can see typically where your cavity barriers are around your ropes, up over the eaves, at the corners. They're typically the red fire socks that are installed. A timber 38mm is sufficient, believe it or not, as well, but to allow for variation in cavity, everyone's using the insulated socks really now. And then you have the fire stopping then around the party wall, goes horizontal at junctions with party floors. And again, where the party wall meets the external wall, you have it. So there's all this comes underneath the timber frame manufacturers with IS 440. That's a typical drawn elevation we'd give out on any one project to show the installers where everything has to go. Must be tightly fitted at joints. That's an important one. Sometimes you can go to site and you can see if a cavity barrier stopping, the next one stopping, and you can nearly put your fist through it. You can see where the cavity's gone too wide, so that it's just it's an area that it must be closely monitored and sized correctly. And And then I suppose that most of the presentation was about fire, so I only realised yesterday that the discussion today was about technical guidance document C. So I've thrown in a few slides then about how we deal with resistance to moisture. So we have to prevent the moisture entering the building, obviously, through from the ground up, and then from the outside with the outer leaf separated from the inner leaf, which we have got in IS 440. It's a drainage cavity. So I suppose where I start here is because these, similar to the fire problem with Part L, improving all the time, the more we improve energy efficiency, and we're talking about zero energy buildings and A1 rated buildings, the more airtight we're making buildings. And airtightness is great for energy performance, but it's also creating other concerns when it comes to moisture resistance. Years ago, we used to put a full vapor barrier to the inside of timber frames, and basically that was trapping the moisture in the frame. It wasn't allowed it fully breathe through. So things have changed. There is much cleverer ways you can prevent the heat loss by having good air tightness, but a healthy home needs to fully breathe as well. And it's the use of very intelligent membranes nowadays that's allowing us mitigate against condensation risk while also giving good air tightness. So vapor barriers, as I said, is what we used to use. That caused timber frames to sweat. Any moisture that was built up in the wall wasn't allowed to escape. Breather membranes used on the outside of the building. Typically, we actually use Protect, which is a good way of doing it. They've blue text for the outer breather membrane and red text for the internal membrane. So then you know which is the VCL. You can't mix them up. And you'll notice they're all foil faced. So nowadays that's key to energy efficiency as well. That reflective foil is radiating the heat back into the service void, and also in the external cavity, it's radiating back into the external cavity. So that's giving good thermal resistance in the air voids. So I suppose the vapor diffusion is what it's all about. We want to manage water at different times of the year, and we want to allow the wall fully breathe. So if we use just a vapor barrier, all that condensation would condensate onto the inside of the wall and cause problems. Yes? Impermeable. There's different types of foil. So there's intelligent type solutions with the foil, and it's all to do with these pin type holes and the molecules of water and vapor. I believe water is bigger molecule, so it won't let the water through, but allows the warm, moist air and vapor through. So they're intelligent foils. So they still allow it breathe. And I suppose warm, moist air will always work its path out to the colder air. So you don't want interstitial condensation, and that's why you need them breathing on both sides. So it's really what's changed in timber frame a lot over the years. That's made you're not worried about moisture damage within frames when you're using these intelligent membranes anymore. And that's the key really of the point with moisture damage. So they're AVCLs, we call them now, airtight and vapor control layers. And the important thing there is the detailing again on site. You have to make sure they're lapped 150 mil on the vertical plane, 100 mil on the horizontal plane. It's all the penetrations taping around. Even the smallest of detail now, we're making houses so airtight, that's a gap. 1 mil gap could be for moist, warm air is going to hit there and cause condensation. So everyone looks at it from an air tightness perspective, but we need to look at it from condensation risk perspective as well. So that's key. Things like the rim board of the houses, that's a thermal bridge. I've seen a lot of manufacturers just put wool there, which is actually allowing a certain amount of moist, warm air through and can cause a condensation build up on the rim beam. Typically what we use is a foil-faced rigid PIR membrane on the rim beam in that scenario. So there's just things like that. I suppose the intelligent membranes are the best of both worlds. You're getting the airtight seal and you're still allowing that control of vapor, that passage of moisture through. And then I suppose we look at the content of the moisture content of the timber itself. So moisture content of timber it's linked to the key properties of timber. So the strength of the timber, the resistance, how it degrades, the durability of the timber over time is very much based on its moisture content. So the structural grades are kiln dried timber. Typically we have to follow EN 13183, and it cannot exceed 18 degrees or 18% moisture content during the construction or the fabrication stage in the factory. Now that moisture content does adapt based on its surroundings, so you just have to follow the standards, the 13183, when you're measuring moisture content of timber, but it's a key factor. And again, once it's leaving the factory, it's wrapped in all these membranes that are allowing it to breathe anyway, so it is a key element. And then preservative treatment, there is requirements based on its service class. So if it falls within service class 1, it does not require treatment. So that'd be your internal walls, your compartment or separating wall buildup, the upper floors, and in a warm roof environment. Everywhere else you do need to treat the timber to the relevant standards. So again, that's an important aspect of moisture control. And then we have from I suppose we've our DPCs, DPMs. So these are used as per your traditional building, really. The bottom, the sides of all your windows, your window sills, around the window sills, the lintel areas. But every sole plate, so the base plate of every wall, ground stairs wall, will have a DPC factory fitted to it. The party wall detail, there's a drainage cavity produced below, and your DPCs are underneath there as well. They're all lapped with your radon, your DPM. So it's more or less similar to standard detail, really, standard construction. And then resistance to moisture, condensation risk analysis is very important. When you're getting U-value calcs done for a particular build-up, it's good to do the interstitial condensation risk analysis on the different build-ups. And we also then thermal model all our junctions. And on the thermal model, you get a condensation risk analysis done as well for your FRSI value, which is the surface temperatures. So if they fall underneath a certain temperature, that cold surface will have condensation risk. So yeah, you should be looking for all the junctions thermal modeled with that FRSI value on them. You should be looking for interstitial condensation risk analysis with U-value calcs, etc. It's another key part. And then I suppose quality assurance on site is key then. We can have these wonderful standards and be audited for them, but if we're not doing a day-to-day management on site, as I said, the ITFMA have that, the approved erector scheme ongoing. We're trying to develop that. But then it's up to each manufacturer themselves to have stringent quality control. So we used to have a paper type of checklist where you'd have to walk around with the client and check every detail in IS 440. Now it's all done with a field wire software. So everything's done on a phone or a tablet. You photograph every critical junction. There's GPS coordinates to each detail for each house, and that links back nicely to BCAR. So the assigned certifier has a full backup files of evidence, etc. So it's key, I suppose, to measurement. No, there's not. I don't know what they're all using. We'd be field wire, but there is other versions I wouldn't be familiar with. But thank you for listening. I suppose the key is what on my finish note is, first thing you should be looking for is manufacturers' NSAI certificate to prove that they're fully compliant with IS 440. And because then they're getting audited, etc. And it's not, if they're a member of ITFMA, they usually are the upper tier of timber frame manufacturer as well. And we're always trying to develop better quality control and standards moving forward. So thank you for your time.